So I teased this build a little bit in my last video where I flew in front of the camera and you could probably see the camera moving on me or you while I was flying and hovering. Obviously it's going from 0 to about 60 degrees camera tilt through a 50-degree session mount on there that I 3D printed. I've got a 55-degree mount coming for my Hero 7 to see if I can get the effect that I was looking for. And part of that effect has a lot to do with what's going on with the 360-1R. And this thing is just kind of stupid, in a good way. The ability to keep reframing and the things that it's doing while it's flying, they're basically selling it as something that you could use to not have to rely, I guess, on racing drones to get these types of shots. They're very similar to what I was trying to get when I started the 360, or not the 360, the 3D builds when I started flying these things. There's one axis that I was pretty much ignoring, which is basically the vertical axis, and that's where I've started to play with this thing. All my CheaterKwads have been very low camera tilt builds. Like for instance, on my 7-inch, the backwards flying cam is down around 5 degrees, if that. The forwards cam is about 10-15 degrees. Same with the FPV cam, they match. So that way when I'm flying backwards, I'm not just looking at the sky. If I was flying this thing backwards upright and I was going aggressively, you can see I'm basically 90 degrees straight up in the sky. So yeah, everything I've been doing so far has been low tilt, but somewhere along the lines I figured out that I can change the axis that I do transitions on to one that's more vertical. And you saw that when I was playing with the light poles. I basically went straight up and climbed straight up the pole, and the goal was at the top of the pole to keep it in frame, invert, and then keep climbing away from it. And that's the dang thing that this 360-1R is basically able to pull off, because the drone completely disappears within the blind spots of the top and the bottom mounted 360 camera. When I started building these, I realized that if I could use a 360 cam, and I played with basically from about 90 degrees straight up to about negative 30 degrees off the center line of the drone, I wouldn't have to worry about camera up tilt anymore. So I've been practicing with a fixed camera in order to get good at my transitions, with the understanding that at some point I'm going to jump into the 360 game. And I've got a CNC mill coming. It should hopefully come within the next week or two, and then I'm going to take a few weeks to hopefully learn how to cut my own frames, ruin some carbon fiber and so forth. I may just be reusing arms from drones that are out there and then making custom top plates and bottom plates. And that's for the purpose of mounting a 360 cam towards the front. I won't worry so much about from the 90 degrees up back, because I don't want to see the drone. I want to focus forwards, and basically in post I'll adjust for what I see based on what I'm doing. The nice thing about it would be is when I'm flying backwards, I can fly more aggressively, and I can use this sphere that's projected out the front of the drone as I'm flying backwards to get back my compounding camera angles that I've been losing, if that makes any sense. So this thing, I want to show you real quick. I'm going to put it about a foot from the door over here, and I'll show you just how much of a change it is on the FPV feed when I go from 0 degrees to 60 degrees. So here I am. I mean, I'm barely 12 inches off the door, maybe even 10 inches off the door. Here's my view. It's kind of a bad view, sorry for the horrible monitor. But as I hit my slider on my controller, I can see straight up above me. So I can go from regular flying, being more efficient, flick the switch, and then I can fly straight up the face of the building and spot my out at the top of it. That's what this thing is for. I'm gonna basically, even if I have a 360 camera, if I have a 360 camera, like the Insta 360 scene, 180 degrees on the top, 180 degrees on the bottom, and the drone disappears. To get next to the building and fly straight up the building, I need to see where I'm going. So this is likely something I'm going to be playing with in the future. I am going to use this much more. And the other thing about it is if I'm climbing up the building and turn around and I want to dive the building, luckily all I have to do is hit the slider on the side of my radio, and now I can come down the building, so where when I'm getting towards the bottom, as I pull out, my thrust angle is going to be more natural than if I'm like this coming down the building and trying to pull out. Flying this thing, it's kind of like Deadpool says, must have worn my brown pants. If you're flying on 60 degrees up tilt, you adjust to it pretty quickly. And then when you're coming down off of a dive, you better remember what you're doing if you've been flying like this a bunch, because your thrust angles change. And no joke, I biffed it twice. They weren't bad wrecks. I killed one servo. This isn't a super durable build. Didn't break my 3D printed mounts, but I definitely stripped the plastic gears out of a little HS55 servo. It's just not that durable. It's not gonna survive a bunch of crashes. But it has been fun to play with. I'm gonna be adjusting this. I'm gonna try and get it tuned better. I'm gonna do what I can with it, see if I can take out some of the vibrations that were seen in my last video. And I'm gonna get a 360 camera. I don't know if I'll be able to get the 361R adopted to an FPV frame, but I wanna try. I've got some ideas on how to keep that thing within an axis above itself so that they're perfectly lined up and centered. Once I get a CNC mill, that should be pretty easy. Even if I have my 360 or a 3D printer, there should be some options there. The big thing's going to be is trying to get it all wired up so that way it'll fit on one of these things and you can still make the drone disappear. If not, I'll just go to a 360 camera and I'll focus on 90 degrees towards forwards and about 30, maybe even 45 degrees down, so that camera's going to be mounted towards the front. And then I'll just do what I can. As far as how I'm controlling the servos, it's just a mix in my radio. Off to the side here, this little slider basically matches, and as I go, I've got it edited in the mix, so where the center point is there, if I go all the way down, it's trimmed out so where it's only going to be right at like basically dead level. And then as I hit full up, I just go stop to stop. It's quick. I don't want to worry too much about, 40 degrees or anything like that. I could put it on a switch, but I didn't. I just put it on the slider. It's not that hard to deal with. Then for the other camera, when I want to switch to what I'm doing with the other camera, this is my switch. So I've got switching from one camera to the other camera on the momentary, and then on the other side of things, I've got this little guy going on. So they're both right next to each other. In the mix, when I flick this switch, this also engages 3D mode. When I engage 3D mode, it's gonna flip all the controls that need mixing. Part of the CheaterKwads solution was in the mix. Bardwell talks about that. He did a video on how to do all the editing on the mixes. But the way I've got it set up is when I don't flick the switch and I'm on the upright camera, I've got throttle set so the 1500 midpoint from here to 2000, and that's basically full range for when upright. When I flick the switch and I'm inverted, that gives me basically like 1490 to 1000. So again, I've got full range on throttle when I'm flying inverted, and it's always like flying a normal quad. So when I'm inverted, it's like flying upright. The only thing that happens is the GoPro can't figure out what the hell's going on because it's a fixed field of view, fixed viewpoint. So without the 5-cell 1300 milliamp hour battery that I have here, you're looking at almost an hour and 20 minutes worth of flight time between 4 batteries. This is a Samsung pack that I built. It's a 6-cell. It's in 2 parallel. It's 4,000 milliamp hour. The Samsung charge rate's only 0.5 C, so it takes a while to charge this pack. Looks like, based on the specs, about a 20 amp per cell continuous rating with a 30 amp burst. So I figure this pack is good for 40 amps continuous and about a 60 amp burst. This is the first pack I built. I got 17 minutes on this pack on my very first flight on my 7-inch CheaterKwad, which is this guy right here. I'm running the 1300 kV Avenger motors. They're 2806.5s. Went to these motors and all of my 7-inch problems went away on the 5-cell lighter batteries. There's a lighter build with the smaller battery, of course. But I had no more vibration issues. I had no more problems with weird harmonic vibrations, whatever they were from the props loading and unloading, who knows. At any rate, once I weighed it down with this thing, it got super smooth. I was cruising around for about 17 minutes at 40 to 45 miles an hour with maybe 15 degrees up tilt. So yeah, 645 gram pack weight for this sucker, the way it looks right now. After that, I went over and I built myself some 21700 cells that are also 4000 milliamp hour, but this is just a straight 6S. It's not a parallel, it's just 6S. It's about 200 grams lighter at about 445 grams. I don't have as much amp rating because it's in series with no parallel, so it's about a 30 amp continuous to a 45 amp burst. 200 grams lighter. I was looking to see if I was going to pick up some flight time, but it's still right about 17 minutes. These cells come down a little bit warmer to the touch than what I'm getting out of the heavier pack. So maybe that's where I'm losing my efficiency. I'm a heavier pack here, but the cells aren't working as hard, whereas maybe these are working a little bit harder. So anyway, there's 8,000 milliamp hour, there's 12,000 milliamp hour. That's a second pack, just a little bit different configuration. And then this thing here, these are Sony VTC6 cells in the 6S2P configuration. 6,000 milliamp hour. I got 23.5 minutes flying off of this pack the very first time I flew it. Again on the 7-inch, cruising at 40-45 miles an hour the entire time. Did some split S's, chased some pigeons, basically had some fun with the pack, and it's about a 40 amp continuous 60 amp burst. This thing went for 23.5 minutes flying, not like a complete idiot, but just cruising and having some fun. It's impressive. I don't know what else to say. It's lithium ions have given me more than enough flight time. I know like the kebabs of the world would probably be bored to death flying for that long without, you know, going into ADHD mode and flying around and going nuts, power looping and whatnot. But then again, the 7-inch that I'm building, it's not really meant for that. Yeah, it can fly for a long time, it can fly close to stuff, and it's just meant to be a really smooth rig. GPS on it, it's got crossfire diversity, it's a cheater, so I've got forwards and backwards cams on it, and I want to take this thing out and just have some fun cruising around out in the foothills and the mountains, maybe a little car chase, fly and follow type stuff with it. This thing will let me cover some distance out in the middle of nowhere. I guess ruin all the things. So it does fit on there, but I have to basically daisy chain 2 straps together when this pack is on there. You can see it barely fits. 645 gram battery with a drone that's basically right at 645 grams with the GoPro on it. So you're looking at about a 1,300 gram all up weight. So yeah, it's a big hefty chunk. If you like cat memes, yeah, this is a hefty one. So whatever, that's what I was flying in the video I posted about 2 videos ago. I actually clipped a branch, knocked off one of these props, and still managed to make it back. I was ready to land the sucker right then and there, but I didn't. I managed to make it across the water and land it. So this has probably been one of my favorite builds to date. I've been struggling to get a good flying 7-inch for a while, and about 6-9 months ago, I met Zoe at the DRL races, and I started talking to her about lithium ions. Also, I think Henry Wotherspoon, sorry if I got your name wrong, talking to them about lithium ions. I've had it in the back of my head for a long time, and finally I said, you know what, I'm gonna buy some cells, I'm gonna build one. Soldered up some cells, and I've got maybe 4 packs flown total that are lithium ion, and every time I've been 17 plus minutes flying. It's just totally different. I could see this being fun with a DJI HD system, like Bob said, where you get out there and you just find yourself exploring, and it's a whole new type of flying. But I don't want to buy DJI stuff. I hope that someone will come out and compete with them, because I don't want to give them my money. I don't like them. So I'm gonna stay analog for a while. There's TBS HV Pro 32 in there. Like it a lot. I've got it right up in the Airstream, so as I'm flying, it'll stay cool when I'm on max power. Hobbywing G2 stack, and it flies great. This has probably been one of the funner builds because I've been struggling with it for so long. I had Radimate RC 7-inch drones. They had the wobble on the 2306 1700 kV motors. I had this thing on some 17 or 1600 motors, had the wobble. As soon as I went to the 2806.5 1300 kVs on 6S, everything went away. It just became such a much nicer, flying, smoother drone to fly. If you're wondering about the mount, I designed it and printed it. It's got a HDLRC GPS on it. I put in a hex cutout, I guess, extrusion, so that way you can slide a SMA connector in there and then you can zip tie it on. It's got a mount for vertical oriented Immortal T. I've got another Immortal T down here on the bottom. This mount itself is not on Thingiverse yet, but I have similar mounts to Thingiverse up on Thingiverse for the Project 399, as well as for some of the Hyperlight frames. And then for the 3D cheaters, I think I've even got some up there for the what are they, the Martian frames that I use. I've been getting GPS dropouts, and so I'm playing around with trying to get some foil mounted in between there for a little bit of RF protection. If I can't get that thing to work on top of the GoPro, which is probably throwing off too much RF for it, I'm probably going to move the GPS maybe somewhere off one of the arms or something, so that way I can get it away from some electrical noise. So I'm sitting here editing and I realized I forgot something. For these lithium ions, on my 7-inch when I fly it, I only take it down to about 3 volts per cell. 4.2 to 3 volts per cell is where I've been flying this. There may be a little bit more capacity left in this thing. I could probably take it down a little bit lower voltage, but what I've noticed is when I'm flying this, that 4.2 volts goes really quick down to about 4 volts. Then you get a lot of time spent between 3.8 volts and 3.2 volts. Like 80% of your pack voltage is in that area. Then once you get to 3.2 volts, it starts to drop pretty quick down to 3 volts. So I'm gonna be putting a throttle cap on the 7-inch quad when using lithium ions. When I'm flying it, I'm drawing maybe 15 to 18 amps, depending on if I'm just gently cruising, which seems to be 40 miles an hour. That's about 14 amps. I bought a RC Toolkit current meter, and I calibrated it so that it's a lot more accurate, so that I'm pretty confident the 14 amps that I'm cruising on is pretty accurate. Looking at like the Avenger motors and what they do in terms of thrust stand performance, if I went full throttle on my controller, I would probably exceed the 40 amp continuous current rating that I have on this. So I went through and on the thrust stand, I kind of went and checked out what they do on different props, different motors. I figure if I go to 50% throttle, I'm probably somewhere around 15 amps per motor, which, not 50, maybe it's around 60%. I'd have to go look at it again. If I was at 60% throttle, that's going to give me about 15 amps per motor, which is going to get me really close to the 60 amp burst. So if I split my transmitters throttled so where 60% is max, only on a full burst would I get to this, and then everything below that would end up being safer for the pack. If I'm flying at 14 amps continuous at 40 miles an hour, I'm well below what I consider my safe continuous discharge rate. With this thing, the cells aren't even warm when I land at 3 volts per cell. Maybe if I was to take it down to closer to like 2.7, 2.6, then yeah, I maybe get, as the voltage drops and the current goes up, maybe I'd start seeing some warmth. These things are happier than the 21700 cells, probably because they're in series versus the 21700s not being in series. So yeah, I figure 40 amp continuous is what this thing can do pretty easily, pretty safely with a 60 amp burst. So I'm going to be doing a throttle cut on the 7-inch, so that way I never go over that 60 amp burst. If I get a 3 parallel pack someday or do something like that, then I'll reevaluate. So for now, so I was referring to a little bit when I was talking about the 14-inch build, I could potentially do a 4 parallel pack and have the thing never draw more current than what the pack can safely give you. My 7-inch is nuts. If I put a lithium polymer on there, I can go full throttle and just fly it like a regular acro freestyle rig. But for long distance cruising and for duration, this thing's not really going to be flying above 20 amps continuous, and if I do, I want to be able to put a throttle cut on it so it's safe. Next up, I've also had some 3-cell builds that I did. I've got a little 3-inch that's about 190 grams dry. When I throw this 155 gram pack on there, it's taken my performance from where it used to be, which I used to get like 4 minutes of flight time on a 650 milliamp lithium polymer landing at 3.8 volts per cell, or like right at storage. There's more usable voltage there, but I hate bringing lipos back up to storage. I like to land at storage. I get less flight time, but then I don't have to take a lot of time to put them back at storage voltage. Anyway, very first pack I built was a 2100 milliamp hour 3-cell VTC4 pack. Very first flight that I flew it with, I got 11 minutes. That was 4.2 volts to 3 volts per cell. I sat there and realized I face palmed and realized I can buy larger capacity packs like the VTC5, 2600 milliamp hour, or the VTC6, which is 3000 milliamp hour. These things gave me, the 3000 milliamp hour pack gave me 15 minutes on my 3-inch. So I look at the difference. I mean, I've given myself 4 times the amount of flight time for double the weight of what a 650 milliamp hour pack weighed on my other drone. It's not an acro rig, it's just something for, you know, cruising. Going back to what Kebab said, you know, if you have a DJI system on your drone and you're out there just kind of cruising and looking at how pretty things can be, lithium ion might be an option. If you're not going to go full tilt, full retard, then why not just have more flight time? So with like the DJI system where it's HD and you're out there just flying around, cruising and looking at stuff, lithium ion might be an option. Consider your throttle caps, try and accurately determine what your current draw is going to be, and then do that. It could be interesting on like a Dave C style 4-inch micro long range. I know he was doing 2-cell stuff and having issues with voltage, but he was taking them all the way down to 2.5 volts per cell, and that was only on 2-cell. A friend of mine, I loaned him one of my 2100 milliamp hour packs. It's a 3-cell. He put it on a toothpick, and he flew 19 minutes on 2100 milliamp hour. He's kind of the same opinion as Kebab, where it was boring flying, but he was out there being boring for basically 19 minutes on 2100 milliamp hour. I suckered him into some lithium ions. He's going to build a 4-cell. He's going to build some 2 and 3 cells. So that way when he wants to go out and just kind of cruise around and putt-putt, then he'll be on the lithium ions. It's kind of an interesting new place to be for playing around with drones. So I've been doing stuff with cheaters. I've been doing stuff with lithium ions, both for long range and for micros. And hopefully you enjoyed the video. Sorry it took so long to explain so much, but